All right, here we're looking at simplifying rational expressions. And when we talk about rational expressions, we're just talking about expressions that are expressed as a fraction. This word rational, when we think about the word rational, we should immediately think about fractions. Because when we think about rational numbers are numbers that are written as fractions. Rational expressions, rational functions, are functions that are written as fractions. Okay, and when we have a fraction, we automatically end up with these things called domain restrictions. So when I think about domain restrictions are just values that x is not allowed to be. It's things that I can't plug in for x. All right, they're restrictions of the domain. Again, the domain is x. What can't x be? And for a rational expression or rational function, the restrictions stem from the fact that I can't have 0 in the denominator of a fraction. So here I am with a big giant fraction, and I have to make sure that the denominator does not equal 0. So I have to find out which x values will make the denominator 0, and those will be my domain restrictions. So again, for a rational function, the domain restrictions are the things that make the denominator 0. All right, so that's what we're going to be looking for here. For example, when I look at this first one, if I've got the 4x over the x squared plus 4x minus 12, I've got a function that's expressed as a fraction. It's a rational expression. All right, so this thing is rational, and I just want to know what can't x be? What are my domain restrictions? Well, for a rational expression, I just have to make sure that the denominator does not equal 0. So here's what I do. I take the denominator, which is the x squared plus 4x minus 12, and I just say that this thing cannot equal 0. All right? And what I'm going to do is I'm going to solve for x here, and I would solve for x the same way I would if this thing said x squared plus 4x minus 12 equals 0. So if it was equals 0, I would solve by either factoring, completing the square, or my quadratic formula. And I always check factoring first, so I'm going to build a bridge. That gives me a negative 12, two numbers that multiply to negative 12 but add to a positive 4, the 6 and the negative 2. And so I'm going to solve this thing by factoring. Again, I act as if it says equals 0, and I solve it the same way. So this thing factors into an x plus 6 and an x minus 2. And instead of equals 0, I just say does not equal 0. And now I set each factor equal to 0, or rather not equal to 0, as it were. But again, I follow the same step, except that instead of having an equal to sign, I have a not equal to sign. And now I solve each. Here I subtract the 6 from each side. So I find out that x cannot equal a negative 6. Here I add the 2 to each side. So I find out that x cannot equal a positive 2. And I can write this, I can kind of sum this up and just write it as x cannot equal negative 6 or positive 2, and write it this way. All right, so I'm setting the denominator equal to 0, or rather not equal to 0, and now I'm solving the same way I solved quadratics previously. Okay, same thing with the next one. I'm going to take this denominator, the x squared minus 9x plus 20, and I say that that cannot equal 0. So now I build a bridge. When I do that, that gives me a positive 20. So two numbers that multiply to the positive 20 but add to the negative 9 are a negative 4 and a negative 5. And now from here, I split this into the two factors. So I've got x minus 4 and x minus 5. Instead of setting these equal to 0, I say they cannot equal 0. And that's the only difference in the way I'm solving these things. So I set each one equal to 0, or not equal to 0, rather. And now I solve each. Here I add the 4. Over here, I'm going to add the 5. And so I come up with these two answers. X cannot equal a 4. And I also find out that x cannot equal 5. All right, so I solve each of these the same way I would normally solve a quadratic, except I say that it can't equal these values. So here, x cannot equal the 4 or the 5. Okay? If I apply the same thing to the next one, this is kind of one of our special cases in terms of solving, which is why we bring this up. This is x squared minus 100. Cannot equal 0. This thing is a difference of squares, so it factors into conjugates. Remember, x plus 10 and x minus 10. So there's no need to build a bridge on this one. I just factor it as a difference of squares. And now I set each factor equal to 0, the same way I always would, or not equal to 0, rather. And I solve each. Here I subtract the 10. Over here I'm going to add the 10. So I find out that x cannot equal a negative 10. And I find out that x cannot equal a positive 10. And once again, I can kind of summarize this as x cannot equal. I can write the negative 10 and the positive 10, or you can just write plus or minus 10. And that kind of reminds us of the other way that we can solve these things. I could have added the 100 and taken the square root of each side. When I do that, I have to do plus or minus. All right? If I look at this one, here again I've got the 2x squared plus 9x plus 10 cannot equal 0. So I try factoring, I build a bridge. So when I build a bridge on this one, it gives me a positive 20, and the two numbers are a 4 and a 5. But then from here, I can't use my shortcut because there's a 2 out front, so I have to split up the middle term. So it's 2x squared plus 4x plus 5x plus 10 cannot equal 0. And now I've got to factor by grouping. So I group the first two together, I group the second two together. Out of the first two, I can factor out a 2x, which leaves me with an x plus 2. Out of the second two, I can factor out a positive 5, which leaves me with an x plus 2. And now I have my two factors. The first factor is the x plus 2, which I say cannot equal 0. The other factor is the 2x plus 5, which I say cannot equal 0. And now I solve each of these. So I find out that x cannot equal negative 2. Over here I have to solve. So I find out that x cannot equal a negative 5 halves. And again, I can kind of sum this up and just say x cannot equal a negative 5 halves or a negative 2. All right? Those are how we work out domain restrictions. Okay? So then moving on from here, once we have domain restrictions, what we want to do is start simplifying these things. So to simplify rational expressions, here's what we're going to do. We're going to start by identifying any domain restrictions. So make sure I have all the values that x can't equal. All right, I always have to do that first, all right, because we'll get restrictions that kind of get canceled out, but those restrictions still exist, all right? So we have to identify the domain restrictions first. Then we're just going to factor everything completely and then cancel out any common factors that we might have, okay? So for example, when I look at this first one, I've got a 5x over the x squared plus 4x. The first thing I do is I say, okay, what are my domain restrictions? And to do that, I set the denominator equal to 0 or not equal to 0. So I say x squared plus 4x cannot equal 0. And I'm just going to solve this by factoring. Here I can factor an x out, which leaves me with an x plus 4. And now I set each factor. So I say x cannot equal 0. I say also that x plus 4 cannot equal 0. And I solve each. This one's already solved. X cannot equal 0. That one doesn't change. Over here for this one, we have to subtract the 4 from each side. So I find out that x cannot equal a negative 4. So I've got two domain restrictions here. So I've got my domain restrictions. Now I actually want to go through the process of simplifying this thing. So I factor this thing as far as I can. In this one, the numerator can't really be factored. It stays as a 5x. The denominator can be factored, and I already factored it once. Don't do this work again. I factored that thing over here when I was solving. All right, so I already factored that thing once, so I just have to copy this down. That factored into an x times x plus 4. And now I cancel out any common factors, and I see that I've got an x in the numerator and denominator, so I can cancel those out. And so what happens is this thing simplifies to 5 over the x plus 4. And what I do is I just put a comment here and say, hey, it simplifies to 5 over x plus 4, except that x cannot equal 0 or a negative 4. Or we can write the negative 4 and then 0. Okay? So basically, we write our domain restrictions, then we simplify this thing by canceling any common factors, and then we just kind of we include our domain restrictions in our final answer, okay? Same thing with the next one. I'm going to start by finding the domain restrictions. So if I identify the domain restrictions here, I say that the x squared plus 2x minus 8 cannot equal 0. All right, so I have to make sure that the denominator does not equal 0. So here I build a bridge and I factor. This one's going to factor into an x plus 4 and an x minus 2. And now I set each factor to not equal to 0, essentially. So I say the x plus 4 cannot equal 0, and the x minus 2 cannot equal 0. And I have to solve each of these. So over here in this first one, I have to subtract the 4 from each side. Over here, I have to add the 2. And so I come up with these two domain restrictions of x cannot equal a negative 4 and x cannot equal a positive 2. Now I'm ready to start simplifying, so I come back up here and say, okay, I'm going to simplify now. So this was just finding the domain restrictions. Now I'm going to simplify. So I factor the numerator. That's a difference of squares. It factors into an x plus 2 and an x minus 2. The denominator I already factored once. Don't do this work again. It's right here. All right, I already factored that once, so I just have to copy that over here was the x plus 4 and the x minus 2. And now what happens is I see that I have an x minus 2 in both the numerator and denominator. I can cancel those out. So I cancel out the x minus 2. So what I'm left with now is I'm just left with an x plus 2 over an x plus 4. But I also have to say, yeah, that it simplifies to this, except that x cannot equal a negative 4 or a positive 2. So I have to include those domain restrictions as part of my final answer. Okay? Let's try just a couple more here. Again, this one I set the denominator. I say that the denominator can't equal 0, so the 2x squared plus 5x plus 3 cannot equal 0. And now I build a bridge, and I see if I can factor this thing. So here I build this bridge. That gives me a 6. The two numbers are going to be a 2 and a 3 that multiply to 6 but add to the 5. I split up the middle term and factor by grouping. So I group the first two terms together and the second two terms together. And here I can factor out a 2x, leaves me with an x plus 1. Out of the second group I can factor out a plus 3, which leaves me with an x plus 1. And now I have to set each of these factors that I can already see forming. The x plus 1 cannot equal 0, and the 2x plus 3 cannot equal 0. Again, I have to solve each of these. So I find that x cannot equal a negative 1. Scroll down a little bit. I also find that x cannot equal a negative 3/2. And so now the domain restrictions are done. Now I want to simplify this completely. When I look at the numerator, I want to factor that numerator. I can factor a 2 out, which leaves me with a 2x plus 3. In the denominator, I already factored this thing once. I already know that the two factors are going to be the 2x plus 3 and the x plus 1. All right? I already factored it once. Don't go through all that work again. You already factored it when you found the domain restrictions. Now I can cancel out the 2x plus 3's. So my simplified form of this thing is a 2 over x plus 1 with the restrictions of x cannot equal a negative 3/2 or a negative 1. Okay? And that's how I express my final answer. All right? If I take a look at the last one here, again, I set this denominator equal to 0. I say that it can't equal 0, so the x squared plus x minus 12 cannot equal 0. I solve by factoring here. This factors into an x plus 4 and an x minus 3. And I set each factor equal. So x plus 4 cannot equal 0. X minus 3 cannot equal 0. And I solve each. So I get my two domain restrictions. X cannot equal a negative 4 and x cannot equal a positive 3. Now I'm ready to start simplifying. When I look at this numerator, the numerator is a difference of squares. So that's going to factor into an x plus 3 and an x minus 3. The denominator I already factored once. That's an x plus 4 and an x minus 3. And now I have x minus 3's in both numerator and denominator. I cancel them out. So my simplified form of this thing is going to be the x plus 3 over the x plus 4. However, x cannot equal a negative 4 or a positive 3. All right? So again, I set the denominator equal to 0 to find out what x can't be. Those are my domain restrictions. Then I factor everything completely, cancel out any common factors, and write my simplified form with my restrictions. All right?